Moving on, we are to use the trigonometric function and find the missing side. And let's observe this right-angled triangle. We are to look with respect to the angle that is being given. The first step is for us to name the sides, so opposite to the angle. This side 5 is the opposite side, and this is the adjacent side, and the side that is opposing the right angle. The longer side is the hypotenuse. Remember that trigonometric function tells us we are to choose two sides from the three sides. So we are to remove one. So this 5 is indeed what we needed because it has been given as 5. And we also need hypotenuse because we are finding the length of the hypotenuse. So the adjacent side is not important. We are to remove that. And now we are to determine the trigonometric function we are to use that involving the opposite and the hypotenuse. You are to recall the acronym. So I believe is SOR. SOR tells you sine theta is equal to opposite over hypotenuse. And now, in place of theta, the angle, you are to put 55 degrees. So sine 55 degrees is equal to opposite. Opposite is 5 in this case. So 5 over hypotenuse. Hypotenuse is x. And now we are to solve this equation. Let's look at this x. This x is at the denominator. We are to multiply both sides by x. On the left-hand side, I believe you should get x times sine 55 degrees is equal to, on the right, I believe x at the denominator, and on the numerator eliminates, leaving you 5. And we are to divide both sides by sine 55 degrees and let x to be the subject of the formula. On the left-hand side, I believe your sine 55 degrees eliminates with sine 55 degrees, leaving you x. While on the right, you should get 5 over sine 55 degrees. And now our task is to turn this sine 55 degrees into a 2 decimal place answer. That is, you are to use your calculator and press sine 55. Remember that your calculator has to be on degree mode. And I believe in 2 decimal places, you should get 0.82. So we are to replace sine 55 degrees with 0.82. Your last step to get the length of x is to use 5 divided by 0.82. And I believe in 2 decimal places, you should get 6.10 as the length of the hypotenuse. Moving on, we are to look at this question in which you have the angle theta as 45 degrees, and we are to name the sides we have. Opposing the angle theta, you should have the x as your opposite side. The other leg is the adjacent, while hypotenuse remains as the hypotenuse, the side that is opposing the right angle. Then we are now to remove one side from the three sides. So let's start from the opposite. We need it because x is being given, and adjacent, we need it because the value of the adjacent side has been given. And so let's remove the hypotenuse. Your first task is to determine the trigonometric function we are to use, that involving the two sides, opposite and adjacent. So you should use TOR. TOR is tangent theta is equal to opposite over adjacent. We should first substitute theta. It has been given 45 degrees is equal to opposite. Your opposite is x, so in place of opposite, you put x over adjacent. Adjacent is 7. We are to make x the subject of the formula and solve. We are to multiply both sides by 7 to get rid of the 7 that is on the denominator. On the left-hand side, I believe you should get 7 times tangent 45 degrees is equal to, on the right-hand side, I believe 7 and 7 gets eliminated, leaving you x. Our last task is to deal with the tangent 45 degrees. That is, we are to use the calculator and get a 2 decimal place answer. So you are to press tan 45 on the calculator, and I believe you should get the answer as 1. Therefore, we are to replace tan 45 degrees with 1. On the left-hand side, 7 times 1 gives you 7 and equal to x. Now we have solved for the opposite side as 7. Moving on, the angle theta has been given, and then you are to identify the 3 sides. Opposes the angle, you should have the side as the opposite side, while the other leg as the adjacent side, and the longer side remains as the hypotenuse, the side that is opposing the right angle. We are to remove one side, and let's remove the opposite. It's neither we are to find nor is being given, so remove that. Think of a trigonometric function that uses the adjacent and the hypotenuse, and that should be cosine. Using the acronym CAR, we know that cos theta is equal to adjacent over the hypotenuse. In place of theta, you are to put the angle, so 30 degrees, cos 30. On the right-hand side, in place of adjacent, you are to put 18 is being given, and hypotenuse is x, the side we are to find. We are to solve for x, so let's turn this x on the numerator first. So we are to multiply both sides by x, x, and x. On the left-hand side, we should get x multiplied by cos 30 degrees is equal to, on the right-hand side, you should get x and x eliminated, leaving you 18. Looking at the left, we have brought this x on the numerator, but you should see that this x is not isolated, it's attached to cos 30 degrees. So we are to divide both sides by cos 30 degrees. And finally, isolate x. On the left-hand side, you should get the cos 30 degrees eliminated. On the right-hand side, you should get 18 divided by cos 30 degrees. Our last step is to turn this cos 30 degrees into a 2 decimal place answer. We are to use a calculator. You are to press cos 30 on the calculator and get your 2 decimal place answer as 0.87. After getting the decimal, you are to replace the cos 30 degrees into the decimal, 0.87. So x is equal to 18 divided by 0.87. we are to perform 18 divided by 0.87, and that ultimately will get you the x. And I believe 18 divided by 0.87 should give you 20.69 in two decimal places. We have found the length of the hypotenuse as 20.69.